Normally, we have situations where clients prefer, say, they have a good electrician. Why would a client opt to have you as opposed to an electrician who will speak the common Wananchi's language, and yet they can do the same job you're doing? Hello and welcome to Kakaan Build Talk series. Today we have an amazing guest with us. Today we are going to be having a discussion with the amazing engineer Alvin, who is an electrical engineer. We are looking forward to you joining us and getting your feedback on the various topics we've been having, and also to hear from you what you'd want us to talk about more. So welcome, Engineer Alvin. Maybe you can introduce yourself and share with us maybe what you do.
Okay, thank you. Thank you very much. It's a privilege to be here. My name is Alvin Okello, Engineer Alvin Okello. I'm an electrical engineer. I've been an engineer for almost 2 decades now. I think I started my professional journey in 2004. I've had a taste of working on what we call the line side, which is the power supply side, working with the electric utility. In the US, I got my degree in the US in 2003. So my first job out of university was working with a company called PHI. Pepco, PHI stood for Pepco Holdings International. They've now been procured by a bigger entity, the largest power utility in the US called Exelon. So I worked there, then came back to Kenya in 2007, where I've been. Worked with a number of consultancies from that time up until now. So my progression has been interesting, my journey. Now on this side, I've been working in building services. I began my career working on the power, the supply side. Now I'm working on the building services side, where you do designs up to the sub-circuit, That means the socket or the light fitting. So that's a little bit about myself.
Thank you. This is very interesting to hear. I didn't know that part about you, that you actually worked from your first job was in the power utility. For those who don't know, the power utility supply side means basically KPLC or KenGen, the supply system. We usually complain about that a lot here in Kenya. But I'm grateful that you've come back to the light, to the good, to the good side of being an electrical engineer. Welcome. Maybe you can share with us what exactly you do in the built environment. That is now what you currently do.
So what I currently do, I would say for the last 17 years or so, my focus has been on, as you call it, the built environment. So the building side of it. When I say I'm a building services engineer, my work primarily has to do with designing. When I design, there's preparation of tender documents, so the tendering process. And then after the tendering process is done, there's the evaluation. We evaluate tenders once we send them out to contractors to price the designs that we carry out. And then there's recommendation on which contractor is going to be appointed to carry out these works. So in a nutshell, it's the full project life cycle of a building. Now on the electrical side of it, the design portion, there's the tender action, and then tender action has to do with preparing tender documents and then going out to tender, sending them out to different contractors to price, evaluating those tenders, and then guiding the client on making a selection on who will carry out that work. And then once that's done, depending on the client, some clients usually terminate your engagement there and say thank you very much, and you don't you don't see them or hear from them again. Other clients say no, you've helped us, we want to continue the journey, so why don't you help us oversee the project? So that's the construction management bit or construction supervision. So that's the last part of the project cycle, second last part. So depending on the size of the project or the scope of the project, it can be a year, it can be 16 months, 18 months. And then once the project is done, typically you find the way things are done here in Kenya, there's what we call the defects liability period. That's when the contractor has handed over. Obviously, this means I'm saying it more for their benefit. The contractor has handed the project over, handed it back to the owner, to the developer, to the client. There's usually a period there, can be 6 months, can be a year, where the client gets to use the property and just make sure everything is working. If there are any issues that crop up at that time, we get called in to try and resolve some of those issues, maybe problems that have cropped up. So that's it in a nutshell.
That's very interesting. When you were talking, you mentioned something about preparation of tender documents. And unlike other consultants in the built industry, let's say for architects and the structural engineers, we don't normally prepare the tender documents. These are usually prepared by the quantity surveyor.
Yeah.
Yours is unique in that I understand you actually, apart from just the electrical drawings, the way we call them, and for the layman or for the local term, we'd say steamer, kuchora steamer. Yeah,
Yes.
kuchora steamer.
Yeah.
You just don't you just don't do the basic, not just the drawings, apart from the design, you also prepare tender documents. Maybe you can share more about that.
Yeah, sure. So as far as electrical design goes, there are different elements, and that's a whole discussion. I don't think we can go into that during this period that we have. But let me try and give a little bit of a breakdown before we even get to tender documents. The tender document has to do with your bill of quantities. So your bill of quantities, you itemize everything based on a drawing that you've come up with. You're able to come up with a list of materials. In the US, they call it a bill of materials. Here we call it a bill of quantities. Yeah. So you come up with your bill of quantities, which is what the contractor will use to issue a rate or a price. It will help determine what the cost of those services will be. Now, before we even get to that stage, there's what we call, as part of the design, we have layouts.
Yeah.
So you've got your regular layouts, your room layouts, and before we even get there,
the layouts being the architectural drawings.
The architectural drawings. Yes. So we get the drawings from you, the architect.
Yeah.
You give us the layouts, for the room, and a lot of other details that maybe will be too technical to go into. Once we get those, we do our design, kind of high-level design. We look at the space, we look at the room, we imagine the use, and if there are issues, of course, we come back to you, the architect, and the client.
We try and resolve. Yeah.
Exactly. Tell us maybe how you envisage using that space. Depending, because the difference, I work on all kinds of buildings, residential, commercial, industrial. So sometimes you need to go back to the end user. You go to the developer says, no, let me get you in touch with the people who will be using this space. Yeah. So they kind of give you an idea and tell you what they have in mind, how that space will be utilized. So with that in mind, we have, before we even put pen to paper, we look at the spaces, we look at the room, what type of room is it? How much light will be required? For example, this space that we're in now, if it's an office, the general guidelines that tell you how much light is required. And so we have to typically do some simulations that, we can decide how many light fittings are required and things like that. Then there are other rules that govern the number of sockets in a space. So it's a bit technical. Before you actually get to do the drawing, you have to look at the space and, if possible, do some calculations, some simulations to figure out how many light fittings are required, how many sockets are required, and then start to put all those things together in form of a drawing. Now, once everything is on paper, you've got your drawing, you've got your lights, you've got your anything electrical, sockets, and so on. You look at the bigger loads. You've got a lift. Maybe that requires a certain amount of power.
By loads, you mean items in the building that actually consume electricity.
Thank you. We use these words every day, so we assume
everyone
understands. Yes, you're absolutely right. It's the electrical load. That is now the power requirement of the items
like a fridge for a house, the microwave, the ironing box, the iron box, the water heater, cooker. Yes. And for the bigger buildings, you're talking about such things as the service elevators.
Yes, you've got your lifts. You've got, depending on the type of building, you've got some electrical loads are even classified as three-phase loads.
Okay.
Those are like the bigger ones. So the houses, sometimes high-end homes they have a steam room. They have a sauna. Loads like that are fairly big, so they're typically supplied as a three-phase load. So you look at all those. Once you've done your basic designs, as far as lighting goes, you now look at all the other things. Then you come up with what we call a schedule, a load schedule. That will help you understand what the overall power requirement is for the building that you're working on. So I think to be a good electrical engineer on the building services side, the one thing I've learned with time is you have to keep your eye on what is that load.
Okay.
Because it'll help you when you approach the utility. We were joking earlier about Kenya Power.
Yeah.
When you go to them and request power, you will need to indicate what the requirement is. Yeah. So I was just trying to build through and navigate throughout this. We've talked about the initial design, the setup, the calculations. Then now once you have all that information, you put them down on a drawing, which we share with you, the architect. Then there's another step for electrical engineers that we call now single line diagrams.
Okay.
So single line diagrams is once you've designed everything, you've put pen to paper, you have a drawing, someone can look at, you see all the loads that are on there. We still have to do single line diagrams. Single line diagrams basically shows the power, let me call it the electrical board. Let me call it that. Simplest term. In our language, we use consumer unit or distribution board.
Yes.
Yeah. So a single line diagram shows everything, every single item in that building, how it's being supplied, how it's being powered, and how you can, the protection on it, how you can, if in the case of
by protection, you mean things like the fuses?
Yes, yes, the fuses, the breakers.
The circuit breakers.
The circuit breakers. So your single line diagram will capture all that information. So for example, if you're doing a house, how many circuits, you know, how many lights, how many sockets are on one circuit. So if there's an issue, you want to work on them, there's a problem somewhere, you can go, look at your single line diagram and know where to go to switch off power to that, so you can work on that without powering down the whole house.
The whole house.
Yeah. So our documents normally include drawings, the bill of quantities we talked about earlier, the single line diagrams, and then now the standard documents where we have what we call the specifications. Now, I want to be clear that, as you said, the QS or the quantity surveyor normally does all the documentation.
Yes.
So what we do is we prepare those items and give them to the quantity surveyor to compile, along with the bill of quantities for the main works.
For the main works.
Yeah.
Okay. So you've talked about circuit breakers, you've talked about loads, line diagrams. I'm wondering, normally we have situations where clients prefer, say, they have a good electrician.
Yeah.
Why would a client opt to have you with all these big words, and as opposed to an electrician who will speak the common Wananchi's language, and yet they can do the same job you're doing? What's the difference?
That's a good question. So what I find with electricians, and electricians are very important in terms of what we do. The electrician is the final one. When the house is being wired, the house is being constructed, the electrician comes in and does the wiring. Normally, he will issue his certificate, you know, for the documentation for that house to be commissioned.
So you're saying even the electrician has to be certified?
Yes.
Has to be a certified electrician?
Yes, the electrician should be certified.
Okay.
Because when the end of the day, when the documents are being submitted, everything is being done, the electrician is very important. You need one who is certified. Now, typically, the electrician doesn't carry out the design. The electrician will be given a drawing, and look at that drawing, look at your single line diagrams, look at everything we've talked about, and carry that out. So that's one challenge, is the electrician doesn't know the concepts of design, doesn't know the requirements. Like for us, what we do, we typically use what's called the CIBSE guide, Chartered Institute of Building Services Engineers. Those are our guidelines that we use for design, but we design to British standard here in Kenya. So many, I'll say like maybe over 90% of the electricians are not concerned or not aware.
Are not conversant.
They're not conversant. They don't need
standards,
to be. For them, they're only conversant with the rules of wiring
and implementation,
earthing, and things like that. But in terms of design and what is required in a space, the electrician is not in a position to even know those requirements. So to answer your question directly, the client needs us because we also add value. Right now, things are changing. You look at what the building services industry was when I came to Kenya, back to Kenya in 2007, and now things have really changed. Back then, there was a lot of what we call incandescent type of lights. The LED lighting phenomenon was not, it was a new thing. Now, typically, every project I design, I only specify LED lights. LED lights are basically lights that use very low power. Yeah. So when I came back in 2007, there were a lot of people still using incandescent lighting, which is the old school lights.
I might have a bulb or two.
And so with incandescent, you see a 60-watt bulb or 80-watt or 100-watt bulb. So it's changed a lot. Now we're even moving forward. Now we've got home automation. coming up. We've got people who'd like to access things remotely. So with people like me, electrical engineers come in handy because you can help the architect, help the client see the options that are there in terms of where we are globally. Okay. Yeah. So electrician might not be in a position to do that. There may be one or two who are interested,
Yeah.
but they're not really maybe
Equipped.
Qualified or equipped.
Yeah.
Yeah.
Yeah. That's, in fact, you've mentioned something that is of great interest to me. In fact, two things, but maybe I can just start with the first one. You've talked about automation, home automation, and that would go very closely with smart homes. Yeah, maybe you can share what role you'd play in ensuring that probably how a home is smart, or what are smart homes.
Okay. Yeah. So smart homes, I've had the privilege of working on a few since I've been in this industry. I think I've done 4. I'm just finishing one up right now. This is a high-end home. It's around a $3 million home. Now, when you talk about smart homes, we're looking at the key driver has been saving in terms of energy consumption. So the market is becoming very, very conscious of that. Governments, I think there are all these goals trying to reduce the carbon footprint. So the building industry is not insulated from that. Yeah. With time, you find people are not trying to save. People are having astronomical power bills, depending on what you're doing, depending on what you're building. So a lot of clients now want to save on what they're paying the utility. So before we get to even smart homes, I'm just giving a general overview. Now we talk of people relying more on solar, just trying to reduce their power bills. And then another thing, in addition to solar, is we talked earlier about LED lights.
LED lighting.
So people go, okay, I want LED lights because I want to reduce my power consumption. Now, when you start coming to smart homes, sometimes you have kids, you leave a light on, or kids go to the washroom, switch on a light, and leave the light on. You come in the morning, you find a light on here, a light on there, and you start wondering, what can we do to save that? So with smart homes, you start having ways to basically, it's a smart home, as the name is suggested. You have sensors and things like that. So if someone leaves a room, after a while, the light switches off. It's another way of conservation. The key thing here has been trying to conserve the power or reduce the power consumption, which has now made homes become smarter. There we're automating. So there's an element of automation. Yeah. The big things that are automated now is lighting. Lighting is a very unique part. When you're an electrical engineer on the building services side, you spend the most time on lighting. Everything else, not even close. That's been my experience. So now, when you start automating lighting, what can we do? If you leave a room, you leave a space, are there lights, something that can switch off the lights in case people forget? And this is also for public spaces, public washrooms, and things like that. So a lot of the smart homes I've been involved in has been automation. Now, I want to make one thing clear. There are specialists, people who specialize on automation. As an electrical engineer, I don't particularly do the nuts and bolts of that automation. What I do is make sure when I'm designing for the lighting, like the way the light switching will be and so on, the specialist who's doing the automation, I give him the infrastructure to allow his
provisions.
The provisions.
Yeah.
Thank you. I give him the provisions to allow his devices,
systems and devices
to
fit
work,
in.
Yes, to work in tandem with whatever we've put in place. For example, let's make that easy. Let me stop using big words. Yeah.
Thank you.
For a regular home, you have your switch, your light switch that you know on off. With the automation guys, they typically call them a touch panel.
Okay.
So instead of your regular switch, they will have a kind of a nicer looking switch. And depending on your budget, that switch can have different modules programmed into it. They can program moods into it and say that from 6 a.m. when you wake up, let these lights come on, but let them be dim. Then by 6:20, let them become bright. So if you're still in bed, you're encouraged to wake up. By 6:40, let them be fully lit. So all those things can be programmed into their modules. And generally, you find in terms of home automations or smart homes, that's what's been happening. The key thing being automated is lighting. In some cases, you have smart sockets. You have smart sockets, and then now we've got the door.
What do smart sockets do?
So smart sockets, it depends. I'll give an example. There are people who have fish ponds in the home. You may have like a little fish pond or fish tank with some fish.
Yeah. Or an aquarium.
Or an aquarium.
Yes.
So you have, with that aquarium, you've got, the oxygen things that filter through it. There's a little light that comes on there so your fish don't get lonely or, be swimming in the dark. Instead of plugging that into a regular socket. Which works on-off, if it's on, it's on.
It's on.
So some nights, maybe at night, you may feel you want to switch it off. If you forget, then that thing will run the whole night.
Bye-bye, Nemo.
Exactly. So with the smart sockets, what happens, if you have a smart socket, you can basically plug that into the wall. There are all kinds of sockets. But with the smart one, there's an element of programming. You can give it program behavior. Yeah. I want this to go off at this time or to come on at that time. Yeah, so that's when we talk of smart sockets in general, that's what we're talking about. Yeah. So the whole thing, when you talk about smart homes, that I'd like us to keep in mind is the whole idea is just saving power consumption, energy consumption, and efficiency. That's what has now necessitated this thing of smart homes. Another thing is remote access. Sometimes with a regular setup, you have your regular home, you leave the house, you're all running, you've saved hard to take your family on vacation, so you're running, you forget to switch off the lights. You go, you're on the plane, and you're asking yourself, I forgot something. I'm not sure what, but I forgot something, yes. Then when you're halfway to wherever you're going, your destination, you realize, I left the lights on. So, and maybe you're gone for a week, and there's no one, there's no help in the house, or a month. Yeah. Those lights will be on the whole month. So now with smart homes, we have that capability worked in to be able to switch them off or control circuits within the home remotely. As long as you have access to Wi-Fi or a mobile connection, like if you have Safaricom, a mobile provider,
service
provider, you can control those things remotely. So that it's the consumption, energy savings, and then also the flexibility of being able to control those things from anywhere. Yeah.
Okay. That's very interesting. I think we should have a whole session to discuss about smart home sustainability. When you talk about sustainability, you're talking about energy sustainability. It's saving you cost at the moment, while you're also saving the planet. Because most of the sustainability, apart from just the savings you're making for yourself, when you're talking cost-wise, there's also some savings. Technically, you're technically saving the planet.
Yes, you're reducing your carbon emissions.
Your carbon footprint.
So you're reducing that carbon footprint.
Yeah. That's interesting. So that I think hopefully we'll be able to pick that up and discuss that a little bit more. A question that I'd want to ask: what are some of the most common questions you get from clients when you're brought into a project? As an architect, occasionally I get situations where I actually have to defend why we need an electrical engineer and a mechanical engineer. But I believe usually after we've crossed there are situations where you actually interact with the client before meeting with the architect, and there are some questions that usually pop up that are very common that you just want to share with us.
I think it depends. Like you've said, there are certain clients who don't even see the value in having electrical engineers or mechanical engineers on site. So typically with those ones, when people like you, the architect, fight for us and we're on that project, they normally don't ask a lot of questions. But the kind of questions I'm getting now from people are a lot more knowledgeable and a lot more interested in saving. The biggest or the most common question I get is, how can we save? Many clients just tell me, I want to fire Kenya Power. That is the most common thing. I want to fire them. What can we do? How can we operate? How can we have service? Is it even possible? How much solar? Will you fill my roof with solar panels? Because the bills are so high. So a lot of questions I get have to do with savings.
Saving costs.
Yes.
Yeah. Is it true that solar usually is actually as expensive as it's made to look, or it's actually you can find a way of probably developing a system where you don't have to power the whole house, or fragment it to suit the different clients' needs?
I think both statements are correct. Solar is expensive, But let me qualify that. And now, unfortunately, there is so much.
I was almost sad.
This is a Pandora's box. When you talk about solar,
Yeah.
this is a whole nother discussion. Let me try and summarize it. As far as power goes, we all know we have one supplier of power.
Yes.
It's a monopoly. In Kenya and also in other countries by jurisdiction, like in the US, they have several states. Where I worked, that company was also a monopoly. So other people are now trying to move away from that model. So Kenya, if you want power, you're stuck. It's Kenya Power. Now, a lot of people are moving to solar. Solar has different levels. There's a question you asked me whether it can be segregated, whether you need to, what that segregation, let me address that first. In our terms, we normally call that essential power. There are services or things that you need in your build, in your home, in your office, whatever type of development it is, that cannot go without power. For example, if it's a bank, there are services services have to be up 24 hours, not 23.2. It's 24 hours. Because someone goes to an ATM to try and withdraw money, and if you're offline for that minute, then that transaction might fail. So services like that, those are called essential services. So you as a client, as an owner of a space, you can determine what is essential. Now, let's just talk for us Kenyans. People who watch Premier League, Arsenal fans, Man U fans, and who depend on, now there are different options of watching online and so on, but the guys who are still on MultiChoice or DSTV, if power goes, and that, what's it called? Is it a router or what do you call that? The box top.
Yeah, the decoder.
The decoder, thank you. When that decoder, if power goes out and the decoder loses its power, that's it. When the power comes back, you'll have to start waiting for it to search, for the satellite to pick up and aggregate. So a lot of people in residential say, no, I want power to stay. Even when power goes, I want that socket, that one supplying, I want power to be there. So they either do solar for that. That is now called essential. Those services are essential. So to keep your solar costs down, you talk to a client and figure out what services they consider essential. Now, you'll be able to save costs because there'll be less circuits being powered on solar. And because there are less circuits, it means less solar panels. And then if they go the other route of storage in our lingo now is batteries. Yeah. So if you have less circuits, which is a smaller electrical load, you have a smaller sized battery, you have less solar panels, and that's where the costing is. The cost of solar panels has come down significantly because China, by the way, China make probably the best solar panels in the world, contrary to popular belief. The costs have managed to come down in terms of what is out there. There are very many local suppliers, but the cost of batteries is still fairly high. So to also lower cost for client, you can have a solution for a client where they have just solar. So during the day, they can use that power, but there's no storage. There's no batteries. Yes. So that's one option. That's how you can save a client money. Say, look, let's install solar panels for you for now. So during the day, we have what's called a grid tie solution. Kenya Power works together with solar in tandem. So if there's adequate sunlight, there's another cost factor is the inverter. I didn't even mention that. The two biggest things that cost on a solar system is the inverter and the battery. So the inverter is like the brain, basically, of the system. Yes. I know for those of you who did physics, you have your inverter, basically you convert your direct current.
Your DC to AC.
To AC.
Yeah.
Direct current to alternating current. All your appliances in the house run on AC. When you generate power using solar panels, that is generated as direct current. So the inverter converts your DC to AC. So in addition to doing that, it's actually the brain of the whole system. With a smart inverter, it can look real time and see how much sun the solar panels are generating real time. It can also assess the electrical load that is connected and say you have a cooker running, you have a light on there, you have this much on. So based on the amount of sun that is there, amount of solar being generated and the amount of load connected, that inverter can make a decision and say, you know what, Kenya Power, relax. We are good for now. We are using solar. But remember, there's no battery. So that's one way to save. We give the client that option. But then what happens? The sun sets. It gets to evening and the sun sets. When the sun sets, you don't have that option. Number one. Number two, if power goes, ironically, during the day, it may be noon and the sun is up. If you lose power, your solar system goes down. Even the grid tie system, I'm telling you, without the storage. The moment it realizes there's no power, it doesn't work.
Okay.
Yeah. So there are different ways of saving. It's a very big conversation. I've just tried to give some kind of top level points. The way to save them is have a system without batteries. The inverter you need, you must have. And then now with time, based on the budget, you can kind of wean them into having batteries. And then if they need more things added, if they want to now save even more, they spend more money to add the solar panels. Usually I try to size for an inverter that if you want to add panels later, you still can.
Yes.
Yeah.
Okay.
So that's kind of...
so it's more like oversizing.
Yeah, you slightly oversize the inverter.
In preparation.
In preparation. So the client may say, I like the way this thing is working. I've saved 30% on my power bill. I want to add more panels. So imagine you've already given the client an inverter, which you have to have for that system, but you sized for a small one. Then you start going back and telling me, I'm sorry.
You need to purchase a new...
And yes, it doesn't make sense. So there's kind of that whole continuum. And a lot of people, let me not say a lot, a good number, a lot is relative. I'm seeing quite a number of people who are now switching and opting for solar. Yeah, in a bid to save.
Okay, thank you very much. I think we've had quite a bit of discussion and we're coming towards the end.
Okay.
Yeah, I know we can go on and on, but I want us to keep it short and sweet.
Sure.
Yeah, they say like a good speech.
Okay.
Yeah, short and sweet, so that next time also you can also come, so that you can continue having more conversations. And just for our viewers who would want to reach you, would you want to share your handles if you're on social media or email or your company, in case they want to reach out to someone who has the experience you have, who is as knowledgeable as you, or just some advice on a project they'd want to take up?
You can reach out to me. I'm on social media. I'm on LinkedIn, very active on LinkedIn. I'm also on Instagram. I think those are the two primary ones. Facebook, not so much. You can look me up as myself, Alvin Okello. You'll get me there. Feel free to send me a direct message with inquiries. I'll gladly answer, respond, because this is something I'm passionate about. I love what I do. I love where the field of electrical engineering is, and I'm more excited about where it's heading. There's so much happening right now. We've barely scratched the surface. You can see I barely gave my host a chance to talk. There was just so much to say. Yeah, so you can search Alvin Okello. You'll get me on any of those platforms. I'm on Instagram. I'm on LinkedIn. LinkedIn is probably a very good platform. You can reach out to me and send me a message, and I can respond and let you know. If you need assistance, if you have any queries, I don't mind responding.
Okay. Yeah. Thank you. And lastly, do you have any questions for me?
No questions, but I just want to say that this is a great idea. This is a great thing you're doing. This is a wonderful forum to allow people like us to be able to share, disseminate some of our knowledge and some of our experiences. It's a great platform for people to learn and know what's out in the market and just to learn from each other, hear things. So this was a good experience for me.
Okay. Yeah. Thank you very much. We are most grateful to have you. We are hopeful that we'll actually bring you again so that we might be able to debunk or talk about more specific issues such as the smart homes, solar system, the energy savings, energy efficiency in homes. I believe, like you've said, your field is totally going to change, and especially with the advent of AI, also we are going to see new aspects come in and how we can incorporate all this to ensure that we have better buildings and also better power systems. So that's in case you decide to jump back to your power system side. Thank you very much. We hope you can like and subscribe, as you heard it from our specialist engineer Alvin, saying that we actually hoping to be able to disseminate and share various information on the building and construction industry so that the different specialists are able to share the various topics and just help ease out some of the questions you have, so that in case you have any question, you can also reach out to them directly or to us with the links provided. Thank you very much, and looking forward to seeing you again.